Hi everyone, my name is Liew Wei Wan and my batch number is BB23110204. So today I'm going to record my video theories for marketing research individual tests. Okay, in this video, I will show my process of analyzing the raw data using Smart BLS. Before I start running the data analysis, I want to explain my planning first. Before using the Smart BLS, I have already prepared my own notes. In my note, I have listed out my variables, research questions, hypotheses, and steps for data analysis. I also draw my framework in my notes so it's easier for me to refer when I draw the model in the Smart BLS. Besides that, I also watch YouTube videos to understand the basic steps in Smart BLS, such as importing the CSV file, drawing the framework, assigning the indicators, running the PLS algorithms, and running the bootstrapping. Based on the raw data given by my lecturers, my study is about turnover intentions. And in my framework, I have three independent variables, which are attitude, subjective norms, and precise behavioral control. My dependent variables is turnover intentions, and my moderator is income level. For my research questions, I want to examine whether attitude, subjective norms, perceptive behavioral control, and income influence the turnover intentions. I also want to examine whether income moderators the relationship between three independent variables and turnover intentions. For my hypothesis, I have five main hypothesis group. H1 is that attitude has a significant positive effects on turnover intention. H2 is that the subjective norm has significant positive effect on turnover intention. Hypothesis 3 is that precise behavioral control has a significant positive effect on turnover intentions. H4 is that the income has a significant negative effects on turnover intentions. H5 is divided into H5A, H5B, and H5C because income is tested as moderators for three relationships. My target for today is to complete the Smart BLS analysis step by step. For this first section, my goal is to import the raw CSV data, draw the model based on my frameworks, assign the indicator to the correct constructs. After that, I will run the PLS algorithms to check the measurements model, including indicators, loading, AVE, composites, reliabilities, and discriminants validity. Then I will continue with the structural model by checking the inner VIF, running the bootstrappings and path coefficients, t-values, p-values, and R-square values. My target is to complete the analysis within 1 day if possible. However, I will still work step by step so that I can avoid mistake and understand the result more properly. Okay, now I'm going to start using the Smart BLS. I have already downloaded the raw CSV data file given by my lecturer. First, I will create a new project and give it a proper name. Okay, after that, I click the import data files and select my CSV file. Now I'm at the Excel import page. Okay, I will change everything to ordinal because they use a Likert scale. For income, I will set it as category first because it represents the income groups. After checking everything, I click import. Okay. Next, go back and select the BLS SEM. Now I am in the Smart BLS models canvas. This is where I need to draw my structural model based on the framework that I prepared early in my note. Okay, I will start with the attitude construct. I will click Q1 ATT, press Shift and select until Q5 ATT. Then I drag them into the attitude construct. I repeat the same step for the subjective norms, precise behavioral controls, and intentions, turnover intentions. For the income, I will assign it as a single item variables because it only represents the income group. After that, I will arrange the model nicely. I will put the independent variables on the left side, which are attitude, subjective norms, and precise behavioral control. Then I will put the turnover intentions on the right side because it's my independent variables. I place the income below the middle because it's my moderator. Now I click the connect tool. I connect the attitude to turnover intentions. Then I repeat the same step for subjective norms and precise behavioral control. I also connect the incomes to turnover intention because I want to test the direct effect of income. Next, I create the moderations relationship since income is my moderators. I use it to moderate the relationship between the attitudes and turnover intention. Then I repeat the same step for subjective norms and precise behavioral control. The dotted line shows the moderations effect. Wait, why is my income indicator is red? I think there is something wrong here. It will not appear red because it's already assigned income into the model. Maybe the problem is from the scale type, or maybe I assigned it wrongly. Let me check first. Okay, after checking the Googles and comparing it with the ray data, I think I found the problem. The ray data income only shows two values, so which are 1 and 2. So actually the incomes only represent two groups. Because of that, it's more accurate to set the income as a binary, not categorical. I think I need to start from the beginning again. This is a bit frustrating because I already drew the framework, but it's better to fix it now before the worst analysis become wrong. So now I need to go back to the data import stage again. I will change the income from categorical to binary because it only have two groups. After that, I will import the data again and resolve the framework. Yes, now it's no longer red. The problem is solved. Now I will continue to the next steps, which is running the PLS SAMS algorithm. Now I click calculate, then select the PLS SAMS algorithm and click start calculations. After the calculations is completed, I go to the after loadings. The after loading shows how strong each indicator measures its contracts. From the result, I can see that all my indicator loadings are above 0.7. For example, the attitude indicators are around 0.836 to 0.885. Precise average control is indicators are around 0.63 to 0.855. Subjective norm indicators are around 0.767 to 0.913, and turnover intention indicators are around 0.826 to 0.895. Since all the values are above 0.7 and show in green, this means that the indicator has acceptable reliability and they measure their construct well. So I do not need to remove any indicator at this stage. For income and the interactions terms, the loading is 1 because they are single items or collected interactions contrast, so it is normal in Smart PLS. After checking the after loadings, now I will continue to check the composite reliability. It can known as CR, and the average variance extracted can be known as AVE. First, I go to the quality criteria, then I click the constructs reliabilities and validity and select overview. From this table, I can see the result for batch alphas and composite reliability and AVE for each contract. Now I will look at the CR first. CR show whether the items in each contract is reliable and consistent. For attitude, the CR value is 0.936. For precise behavioral control, the CR value is 0.914. For subjective norm, the CR is 0.941. For the turnover intention, the CR value is 0.638. All the CR value are above 0.7. This means that all the contracts have good internals and consistency reliability. Next, I will look at the AVE, which means it used to check the convergence validity. For the attitude, the AVE value is 0.747. For precise behavioral control, the AVE value is 0.680. For subjective norm, the AVE value is 0.763. For turnover intention, the AVE value is 0.753. All the AVE values are above 0.5. This means the contract has acceptable convergence validity. In simple words, the indicator can explain their own contract well. So based on the CR and AVE, my measurements model is acceptable at this stage. Now I will continue to check the discriminant validity. I choose the HTMT, which means the heterothreads monothreads ratios. Okay, then I select the HTMT metric. HTMT is used to check the contracts in my models are different for each other. The rule is that the HTMT values shows be below 0.9. From this table, I can see all the HTMT values are below 0.9. For example, the HTMT value between attitude and precise behavioral control is 0.784. The value between the attitude and subjective norm is 0.755. And the value between attitudes and turnover intention is 0.765. For precise behavioral control and the turnover intentions, the value is 0.759. For subjective norms and turnover intentions, the value is 0.816. Although 0.816 is the highest value in this table, it's still below. This means the contracts are still different from each other. So based on the HTMT result, the discriminant validity is achieved. This means each contract in my models measures a different concept, and there is no serious overlap between the construct. Next, I will continue with the structural model assessment by checking the inner VIF values. I go to the collinearity statistic. Then I select inner models metric. Inner VIF is used to check whether there is a collinearity problem among the predictors variables. This means it checks whether the independent variables are too high related to each other. The common rule is that the VIF value should be below 5. From this table, I can see that most of the VIF values are below 5. For example, attitude is 3.595, income is 1.043, and precise behavioral control is 4.138. For the interpretations terms, the income persistent behavioral control interpret terms is 4.294, and the income subjective non-interpret terms is 4.234. However, I noticed that the subjective norm has a VIF value of 5.233, and the income's X attitude interactions term has a VIF values of 5.005. This means there may be a potential collinearity issue for this predictor. Now I feel a bit worried because some values are red, but the values are only slightly above the threshold. I will not change the red data because the data must remain original. Instead, I will report this result honestly and continue with the analysis. Okay, before I continue to the next step, I want to do a quick time check. It's now 2:30, and I have been walking for about 30 minutes. At this point, I feel a bit tired because I have already completed several steps and solved the income scale issue early. So I will take a short 10-minute break to avoid a careless mistake later. Okay, now I am back. After a short break, I feel more focused. So I will continue with the bootstrappings. I go back to the models and click calculate and select the bootstrappings. In the setup, I use 5,000 subsamples, choose one tail test and click the start calculations. After the calculations is completed, I go to the final results and click the path coefficients. Here I can see the path coefficient T value and P value for each relationship. For attitude to turnover intentions, the path coefficient is 0.2, the P value is 1.610, and P value is 0.0054. Since the P value is above 0.5, okay, this means the relationship is not significant. For income to turnover intentions, the path coefficient is negative 0.49, the T value is 1.652, and P value is 0.049. This relationship is significant and negative. For precise behavioral control to turnover intentions, the path coefficient is 0.316, T value is 0.2011, and the P value is 0.0022. This relationship is significant and positive. For subjective norms to turnover intentions, the path coefficient is 0.380, T value is 2.612, and the P value is 0.005. This means the relationship is also significant and positive. For the moderations effect income times X attitude has a P value of 0.286, income X precise behavioral control has a P values of 0.276, income X subjective norms has a P value of 0.425. Since all are above 0.5, the motivation effects are not significant. Overall, the income perceived behavioral control subjective not significantly influence the turnover intentions, attitude is not significant, and the income does not significantly moderate the relationship. Next, I will check the R-square value. Wait, why is there no R-square result here? Let me read the message on the screen first. Okay, I think I found the issue. Smart BLS says the result is not shown because of the bootstrapping setting. I have selected most important factor early, so some additional results are not displayed. To fix this, I will have to go back and recalculate the bootstrapping. I click calculate and select the bootstrapping again and change the amount of result to complex lower. I keep the subsample at 5,000 and the test type as one tails, then I click start calculations again. Now the R-square result is shows. For turnover intentions, the R-square value is 0.667. This means the attitude subjective norms, precise behavioral control, income, and interactions effect experience 66.7% of the variance in turnover intentions. In other words, 66.7% of the changes in turnover intentions can be explained by variables included in my models, while the remaining 33.3% may be explained by other factors that are not included in this study. Overall, an R-square value of 0.667 indicates that the model has a good explanatory power because it is able to explain more than half of the variations in turnover intention. Therefore, I can calculate that the predictors in my model provide a strong explanations of turnover intentions. After getting the bootstrapping result, I compare the finding with my early hypothesis. For the H1, I expect attitude to have a significant positive effect on the turnover intentions. The result saw a positive coefficient of 0.2, but the p-value is 0.054, which is slightly above 0.5. So the H1 is not supported. For H2, I expect the subjective norm to have a significant positive effect on turnover intentions. The result saw a positive coefficient of 0.380 and p-value of 0.005. So H2 is supported. H3, I expect the precise behavioral control to have a significant positive effect on turnover intentions. The result saw a positive coefficient of 0.316 and the p-value of 0.002. 0.022, so hash 3 is supported. For hash 4, I expect the income to have a significant negative effect on turnover intentions. The result show a negative coefficients of negative 0.149 and p-value of 0.049, so hash 4 is supported. For hash 5a, the income x attitude moderations effect has a p-value of 0.286. For hash 5b, the income x subjective non-moderations effect has a p-value of 0.425. For hash 5c, the income x persistent behavioral control moderations effect has a p-value of 0.276. Since all these p-values are above 0.05, hash 5a, hash 5b, and hash 5c, they are not supported. Overall, the supported hypotheses are hash 2, hash 3, and hash 4. Hash 1 is not supported because the p-value is slightly over 0.05. And moderations hypotheses are not supported because the income does not significantly moderate the relationship in this model. I have completed the analysis. I want to reflect on my smart PL as a video derived. Looking back, the hardest part was when the income indicators appeared in the smart PLS. I feel confused and frustrated because I had already drawn the framework, but I realized that the issue was from the scale type. After checking the red data, I found out that the income only has two values, which were 1 and 2. So I has changed the incomes from categorical to binary, and the problem was solved. Another challenge was when I checked the inner VIF values. I feel worried because the subjective norms and income X attitude interactions terms were shown in red and slightly above 5. At first, I thought I might need to change the data, but I realized that the red data should remain original. So I decided to report the result honestly and continue with the data analysis. I also faced a problem when the R-square results did not appear after the bootstrapping. At first, I was worried because R-square was one of the required output. Then I checked the message in the Smart PLS and I found that I need to change the amount of results from most important faster to complete slower. After running the bootstrapping against the R-square result appeared. After completing the analysis, I realized that I was initially confused about the R-square value. I thought it will appear after bootstrapping, but later confirmed that it actually comes from the PLS algorithm's structural model results. This did not affect my final result as R-square's value remains the same at 0.667. I learned that when I get stuck, my first reaction is to feel nervous and worry what I did something wrong. But in this project, I try to stay calm, check Google's, read the message in the Smart PLS, and refer back to my notes. Taking a short break also helped me because I feel more focused after resting. If I were to do another project like this, I will change my habit by checking the red data scale type and Smart PLS setting more carefully before starting the analysis. This can help me to avoid repeating the same mistake and set more times. Overall, I'm proud of myself because I was able to complete the Smart PLS analysis step by step. Even though I faced some problems, I did not give up. I managed to solve the issues, understand the results, and interpret my hypothesis properly. This video diary helped me to improve my personal skill because I learned how to work independently, manage my time, solve problems, and reflect on my own learning process. That's all from me. Thank you.